Alright, I'm not sure if it is resolved or not. Can you see the slide in the background? Cannot see. Alright. Okay, can I give you YouTube to join from the YouTube? The YouTube will be delayed a few seconds. I send the link. Okay, we try another one, another time. Can you see my screen or no? Uh, how about my screen on my computer? All right. What I want to do is that I will stop my WebEx sharing. All right. Yeah, you can follow the YouTube, and I'm sorry for this inconvenience, but you can still participate with me on the uh, WebEx. The YouTube will be delayed a moment. All right. I would suggest you mute the WebEx and just hear the voice from the YouTube. So we talk about what is manufacturing. Manufacturing is concerned with making products. We can see on the left These are some micro gears. These microscopic gears, they are made for spatial mechanism of movement. Usually it is for micro electromechanic process. Here there is a micromirror. This micromirror is being made in order to precisely control some of the things that which is available. If you look at it here, these are some uh, comtits which is made for special applications. The scale bar, if you look at it here, the scale bar is here is shown 100 micrometer this scale from left to the right. With respect to technology selection, we first have to understand what type of material that we want to use in order to fabricate a product. The material can be metal or non-metal. The metals, they are coming from different classification, but the main general ones are the ferrous metal and alloys, and the other one is a non-ferrous metal and alloys. The non-metal one, the foremost is ceramics, organic polymer, or it can be any other material. For example, we have wood, we have other composites, which is mixture of, it can be a mixture of, for example, metal ceramic composite, or can be also polymer composites. So there are different types of metal. And these engineering materials, the ferrous, they coming in different alloys like carbon steel, alloy steel, stainless steel, or tool or die steels. The non-ferrous metals, we have aluminium, magnesium, and all these periodic table that you see, the middle one, they are metals that can be used, some of them for part manufacturing. And there are some special alloys that have different properties. We have super alloys, we have shape memory alloys, and other things. Some of these metals, they are coming from a low melting point. Some of them, they're coming from a high melting point. For example, the high melting point, if you want to suggest to fabrication by casting, then there should be different understanding. The plastics, we have thermoplastic, thermosets, elastomers, and each of these, they have their own manufacturing process, but usually it is on lower temperature that we can use. Then ceramics, glass ceramics, graphite, diamond or diamond-like material. The composites, reinforced plastic, metal matrix or ceramics matrix composites. Then we have nanomaterials. When the material is downsized into a nanoscale, the properties of the material is going to be different. The materials in nanoscale, they have unique influence. For example, we can use the nanomaterials in order to, let's say, inject into the body when it is there are some processes that you can encapsulate the drugs in drug delivery to the body. This drug delivery to the body is very helpful. For example, for the cancer therapists, they don't want to poison all the body with the chemotherapy medicine or drug. They just move it to the tissue which is need this medicine. Then we have shape memory alloys, or they call it smart material. These shape memory alloys, they are kind of alloys that when you change the temperature, they can go back to the previous state of the shape. That's why they call it shape memory alloy. We have amorphous alloy, semiconductor, and superconductor. These are all the materials which call it engineering materials. Now we need to understand the material properties. First, the strength of the material we want to use, the ductility, whether we can draw it into a wire or extrude it or not. We have malleability, which is talking about drawn into the sheets, brittleness, the fracture when force applies. Then we have toughness, is ability to absorb energy until you can see the fractures. Or hardness is the moment that we, for example, indent some uh, harder material into another one. Usually we are measuring this by the diamond tip, which is pushed against by a force on the surface, and then the mark which it leaves, we try to calculate the area over the force, and then we can have the hardness understanding. Then we have elasticity and also resilience of the material and how much it can absorb energy until it deform elastically. Okay, this table is talking very generally about some of the alloys that what we can do with them. For example, aluminium, we can do casting, which is very good. Weldability is fair, machinability is excellent and good. Whereas for the gray cast iron, the gray cast iron is a kind of cast iron is used for, let's say, we have a machine tool, the frame, the structure that they want to make it rigid and stiff, they make it from gray cast iron. So the castability is very good, is excellent, but the weldability is difficult. But machinability is good. It means that for this kind of material, if we use casting, then we can simply do the machining. It is good, but if we want to add another component to it by welding, it is very difficult. Therefore, we use, for example, fastening joints when we are having the cast iron. Also, the white cast iron, the castability is good, but the weldability is very poor. And also machinability is very poor because the hardness is high. It goes to the nickel, which is quite fair, but we have to understand nickel alone is not a material that we use for fabrication unless it is the turbine blade, which goes with the single crystal superalloys of nickel. Then steel itself, the weldability is excellent. You saw in the workshop you go, they can simply do the welding. The steel structure outside, it is made by steel and simply they are welding it. And then we have zinc, which is very easy to cast, difficult to weld, and we can simply machine it. And from the very basic information, we can decide on the manufacturing classification. There are some classification, we have already reviewed this in the beginning of the manufacturing technology one. The primary shaping process we have is like drawing, material drawing, or we have casting, forming, machining, joining, additive manufacturing, or we have different types of cutting like laser cutting, wire cut cutting, and the machining also it includes the EDM die sinking. There are some factors in comparing manufacturing technologies. We need to, if technology, what is the advantage? For example, advantage means that what we can achieve if we are going to use this process, that technology in order to do the machining. For example, advantages is, let's say, if we want to cut something, if you remember the wire cuts, we had, we could simply cut sheets of material, or we could cut some kind of thicker material without sacrificing the quality of the cutting edge. For example, in wire cut, you do not have the divergence of the cutting, which, if you remember, if I can draw something in here, okay. Okay, in wire cut, so the wire is passing through the thickness. This thickness, this is the part. We don't have, for example, the area which is cut is almost same from this edge to this edge. But if it is a water jet cutting, so when we have water jet, depends on the velocity of the jet. If you remember, we could have different types of edge which is remaining. For example, it could be like this, and or it could be like this. So the quality is going to be changed. The complexity of the job, the cost factor, how much is it going to worth for us in order to make such a product using such a technology? How many of them do we want to produce? And also disadvantages and environmental hazards. Some processes, they are chemically toxic, we have to be careful about. It can give risk to the human or to the worker. Then there are factors to be involved. Therefore, in this process, we need to have a selection strategy. For example, one single component, we can use several processes in order to manufacture it, but how we are going to narrow down our understanding in order to get this technology selected? For example, shall we look into the numbers of parts we want to make, the technical capability, the economy, or the component size, the geometry, the tolerance, surface finish, capital equipment, labor cost? All this is contributing to the strategies that we want to use for selections. And for these selection strategies, we have some drivers. As we mentioned earlier, we want to re-emphasize on this: the product quantity, the equipment cost, tooling cost, processing time, labor intensity and work pattern, process supervision, maintenance, energy consumption and other overhead costs, material costs and availability, material to process capability, component form and dimensions, tolerance requirements, surface finish needs, bulk treatment and surface engineering, and process to component variability. And how about the waste? Can we do the recycling of the components? For example, when we are choosing machining by removing material, so the parts with the chips, we can collect it and return it back to the foundry in order to reuse it for casting again. In order to select, we have a matrix which is called Manufacturing Process Information Map, PRIMA. This PRIMA is a selection matrix which shows material and process which is usually taken into practice. We can have a rough comparison of cost with different forms of starting material. I will show you later a typical example of the primer. The strategy for selection manufacturing process, one of them is to obtain an estimate of the annual production quantity. As I mentioned, we need to understand what type of material we are going to use. So choosing a proper material that is satisfying our product design specification, or we call it PDS. Then we have in the next slide, sorry, it is not the previous slide, it's in the next slide. We have to select the candidate for primer, and considering each of these primer against the engineering and economic requirements, we need to understand the process and its variation, consider the material capability, assess the conformance of the component concept with the design rules, compare the tolerance and surface finish requirement with the process capability data, and also we have to know and consider the economic position of the process and obtain the cost requirement estimation for that alternative. And finally, we have to review the selected manufacturing process against the business requirement. With respect to the manufacturing process, we have some requirements for the primer. The material type. The second one is the quantity per annum. I'm just trying to rephrase this that you get this into account. Understanding of the material is very important for us. The process that we are going to choose. For example, we are receiving a component that they ask us that this component should have a certain hardness, it should have a certain creep fatigue behavior, it should have a certain tensile strength, and all of this. For example, they say that this should be, let's say, CK45, which is heat treated in this condition according to this standard. Therefore, understanding of the material type is very important. We choose a proper parent material that we can use for our manufacturing process, which is a key technical to selection factor. And a lot of engineering material, they can be post-processed in order to add a few properties to it. For example, the ferrous alloys, they can be used for a lot of technological selection or manufacturing selection. The parts can be made from the ferrous alloy, and then they can be heat treated or they can be post treated with another thing. And production quantity also, it helps us to understand the economic feasibility of the manufacturing process that we're going to select, which is we have a range of, for example, quantities, depends on the volume from 1 to 100, and we have low volume 100 to 1000, and later we will see how does this affect for this one, or medium volume, and then we go for the mass production, which is 10,000 to 100,000 piece. I am not sure how is the quality of this table. Unfortunately, it is quite small font, but what I want to say that in each of these fields, a list of manufacturing code is given. Later I will share the chapter PDF for you that you can read it through to see the details. For example, when we have the quantity of between 100 to 1 to 100, so depends on the thickness, we can see what kind of material or what type of manufacturing process it is available to us. These are not standard. These are just coming based on some observation and some recommendation. At the end of the day, as a manufacturing engineer, we have to decide on the material, on the process itself. Let's say this is a baseball bat. This one is made from a metal, aluminum alloy, most likely. This one is made from composite, polymer composites. So it depends on what we are spending on it. So the price will be different, the cost of production will be different. This is a laser cutting that we have seen. So we can do precise cutting. Depends. Either we can use blanking in order to cut this, or we use laser cutting. So it depends on how many we want to produce, the accuracy, the time. For example, if we have a laser machine, we receive a smaller number of production. Let's say they want only 100 from these metals to be made. For example, what is required, it is the blank which is left and which is fallen below. So are we going to make a die and mold in order to make the blanking? Or if we have a laser cutter, so why not we employ the laser cutter to cut it if the production quantity is not that high? This is a welding line. If you see several kind of manufacturing technology is combined in order to be observed and or in order to satisfy the requirement of a simple welding. We have different kind of if you see in here, these are stands, or we would say that is a work holding, because this one is our workpiece. The body is the workpiece. Here you can see they can be some kind of coordinating measure in order to see if the car is in position. The robotic arm, which is coming for welding. So this is all plays a role in order to see what is the manufacturing capability we have. In simple form, the manufacturing cost is breakdown into few factors. The first is design, around 5%. Material itself, takes around 50% of the cost. We have direct labor and indirect labor. So these factors can be changed. The material cost is almost same in many countries, but the labor and engineering costs can be changed in different countries. That's why you can see the companies from Western countries, they come and invest in Southeast Asia or in China, because what they can do is that in order to increase their competitiveness or to reduce the product cost or increase their uh, margins, they come here because here the labor is not as expensive as in the US or in the Europe. So still they can produce the parts with designated quality but in a lower price. When we have less than 100, we can do the production in, we call it job shop. It looks like a workshop. We are using technologies such as lathe or turning process or other cutting. We go for small batch production when the number is we have similar parts we want to make and it is more than 10 or between 10 to 100. For this part, we are going to design a kind of tooling and other work holding devices in order to help us in order to produce. Then when it goes for batch production or mass production, the technology will be different and we have to consider this over a certain period of time, which is 2 years, 3 years, how many from this product we want to produce. The mainly it is apart from the technological limitations, we have to understand the economic consideration in determining the appropriate process and what type of machinery we are going to use. Okay, this is the end of slide for now. What I want to do is that we're going to review some of your videos and I will pull up the assessment so your peers they can watch the video. Okay, for those they haven't done the attendance, please do the attendance. You can participate in the class either by the YouTube or WebEx. Okay, do you hear my voice from YouTube or from WebEx? Okay, Lim Kwan Hoi is still absent, right? All right. Okay, let me see if I can switch this sound to the I would play. Okay, I don't know who is this, but let's start from his video or her video. Uh, Check if you can scan the barcode. Okay, Anis Mastura Binti Azhan. So we will review her video. I hope you can hear the voice. So have you scanned the barcode? If you scan, I want to show the video. Oh, Anis Mastura, did you send the video? If you hear me, Anis Mastura, can you text please? Or you talk to the mic? You haven't uploaded any video. Muhammad Sharifuddin, also you haven't uploaded the video. Okay, I was very specific that you need to have video.
this is the presentation for the introduction.
Okay, and it's Mastura. You need to convert it to a video. Uh, do you guys can hear sound on the slide or no?
Okay, this is the presentation coverage. Topic to be tackled is Introduction to Electron Beam Machining, Mechanism of Electron Beam Machining, Limitation, Advantages and Disadvantages of EBM. Based on the limitation, is there any current study to resolve such limitation? Examples of parts manufactured by such a method. That's
Okay, I go for another student.
Evening, Dr. Reza. My name is Chai Chong Yen.
What is your metric number? Chai Chong Ying. Okay guys, when you are posting a video or an assignment, you need to name it properly according to your name and metric number. We do not remember your metric number. Okay, please scan this barcode.
Today, I'm going to present about laser. Evening, Dr. Reza. My name is Chai Chong Yen. Today, I'm going to present about laser beam cutting. First of all, laser beam cutting works by remove parts of material by high power laser. It melts, oxidizes, burns, or vaporizes the surface of the material. so that the material can be cut into desired shapes. There are many types of laser, but the most commonly used laser are the carbon dioxide laser and neodymium laser because it is suitable to cut most of the material. And then the working principle of the laser beam, it is worked by separating the external energy to the laser material so that the electron inside the laser material will receive energy to a higher excitation level. When the electron fall from the higher excitation level to its ground state, energy will release by the electron, which is a form of coherent light. And then the coherent light will then be directed by the optical lens to the nozzle, which is the work zone. And then the energy gathered, which is laser, will melt and pierce the workpiece into the desired shape. Here we comes to the equipments and main parts of laser beam cutting. First is the power supply, which is supplies external energy to the electron. Second is a laser discharge tube, where contains the laser material inside. Third one is a laser material, for example, is the carbon dioxide and neodymium. The fourth one is focusing lens, which is a convex lens that will focus the laser to the nozzle. And then is the application of laser cutting in industry. First of all, it's a laser vaporization cutting. It works by directing high laser beam into the workpiece. The workpiece started to boil and vaporize. The steam is then blown up by the acid gas. And then second one is laser melting cutting. Laser melting cutting is similar to vaporization cutting, but the workpiece is only melt but not vaporized. The molten of the workpiece will then removed by spraying inert gas like argon and helium to prevent oxidation reaction. The third one is laser oxygen cutting. Similar to other laser cutting, but the acid gas is replaced by the oxygens, so that oxidation will occur when the cutting process, and then the molten oxide will then removed by other acid gas. Here comes to the advantage of laser beam cutting. First of all, the cutting process is more quicker because the technology used are mostly automatic that doesn't require so many manpower. Second, holding of the workpiece is more easier than the mechanical cutting, which is most effort. The third one is very accurate dimensions of cutting, which is preferred by many industry. Less wear and tear of the machines. It is because the laser beam cutting is a non-contact cutting process, so that it doesn't wear and tear so much. Next one is fine edge cutting of workpiece compared to traditional thermal cutting process. And the last one is high of versatility. They're able to cut delicate design on different metals. And then the disadvantage of laser beam cutting. First, it consumes very much power, which is not economical friendly. Second, difficult to cut brittle material. It is because brittle material have high thermal gradients that does not conduct heat energy easily. The third one is the cost of the laser beam machine is moderately high. It is because the integrated lens inside the laser beam machine is too expensive. And then it also requires high trained expert to do the maintenance of the machines. Lastly, it's not suitable for mass production because the cutting process might take quite a lot of time. And then the current trend of laser beam cutting. First, performance increased by high power density. 5 years ago, laser beam cutting are still using 4,000 kilowatts, but nowadays the technology has advanced to 6,000 kilowatt and even more higher. By increasing the power, large cutting range can be covered and the higher production speeds. Second, new nozzle technology have lowered the consumption of gas so that the laser beam cutting can able to cut more thicker material with the lowest consumption of gas, which is very economical friendly. The third one is the high pressure air cutting that reduce cost per part. The traditional laser beam cutting using 150 psi compressor, but now the new technology has reached up to 500 psi compressor. The high air pressure are suitable for more material and can produce high edge quality. Lastly, in conclude, technology of laser beam cutting become more advanced year by year because laser beam cutting is preferred by most of the industry due to its high flexibility, high quality finish, and economical friendly compared to other methods. Thank you.
Okay, thank you, Chai Chen. Uh, please give him what is, let's say, a peer mark. So you have the opportunity to give your feedback because this is a kind of presentation that we could have it in the normal class that we don't have the opportunity right now. So I would say that this is a good opportunity for us, all of us, that we can just attend the class remotely. And therefore, I would like the feedback from the class to give to each of the students. It is confidential and we, we don't share what you have given for your friends, but please give a fair mark to your peer. I will start the next video after 1 minute. So I just give you the time that you can key in the marks to your friend. Alright. The next video I would see 279. Abdul Rahman.
Assalamualaikum warahmatullahi.
Okay, some of you just uploaded a presentation file. Uh, as I mentioned, you need to upload two files. One is presentation, the other one is the video. If you do not submit the presentation file, how I can access it? The video file. Uh, the other thing is that I was very specific on the cover page, what information to be written on in the cover page. So this video that I'm showing now, it is good. The cover page is very complete. So I should have the understanding of who is the student, and then since we are going to keep this in OBE, therefore they should have a proper annotation and also information. All right, I will show the video. Okay, Lim Si Yi cannot hear the video.
Wabarakatuh. I'm Abdurrahman Noaim bin Mubarak, and today I will talk about electrical discharge machining. For introduction, electrical discharge machining (EDM) is also known as spark machining. It is a process where electrical discharge was used to produce parts in desired shape. It is a non-traditional method in which material is removed from a workpiece using thermal energy. EDM does not need mechanical force in the removal process. For mechanism, EDM is a regulated metal process that based on erosion of metal by spark discharge. Electric spark were used to cut the workpiece as the cutting tool. This step is carried out by applying electric discharge of high frequency current to the workpiece through the electrode. The spark creates eliminates very small chips of metal, and the dielectric fluid flush away the debris. There are two types of EDM. First one is sinking EDM. In sinking EDM, repeated electrical spark control was used to reproduce the electrode form into the workpiece. The machining area has very high temperature. New electrode is usually used for finishing because the electrode were in the rough machining process. This method uses hydrocarbon dielectric fluid. Second one is wire extend EDM. In wire extend EDM, a small diameter metal wire follows the direction for cutting a piece of work. Distinct sparks produced between both wire and workpiece will trigger eroding in the machining area. The wire that were used in this process has small diameter. Dielectric that commonly used in this method is deionized water. There are some limitations in EDM process. Firstly, sharp corners of workpiece is hard to be manufactured. Secondly, EDM process only works when the workpiece and tool material is electrically conductive. Lastly, EDM process is slower as the size of the hole increases. These are some improvements to overcome this limitation. Developing a strategy of continuous variation of cutting speed limitation along the corner. It will help to produce sharp corner. Introduction of magnetic field will improve waste removal from the machining area, thus increase the process output. Innovative simultaneous flushing and vacuum-assisted debris removal system was studied, which facilitates the better debris removal for deep hole EDM drilling. For advantage, all material that is electrically conductive can be removed using an EDM device. Tough workpiece may be machined to remove the thermal deformation. Parts of complex dies and molds can be manufactured reliably, more easily, and at lower cost. Small delicate parts such as webs or fins are easily machined without deforming the piece. For disadvantage, slow removal rate of materials, price and extra time, only able to process conductive material, high power consumption, sharp corners on the workpiece are difficult to replicate due to electrode wear, excessive wear during machining. These are some examples of parts manufactured by EDM process: stamping die, mold, lathe tool, pot and wobble broaches, extrusion die, and templates. Okay, that's all from me. Thank you.
All right. Okay, please give the scores to Mr. Abdurrahman. All right, we go for the next presentation. Can you please load the feedback? Guys, it's very difficult for me. It's a one-way communication. If you could participate in some way to the class, it was much easier for me. Just interact in a way that you feel comfortable, either in the chat box in the YouTube, or you may text in the WhatsApp group, or even on the Cisco WebEx. Okay, the next presentation is Aidil Azwadi. Okay, let me find him. And next time when you have assignment with any lecturer, uh, please follow the instruction which is given. If you look at the instruction, we ask you to make the presentation. We were trying to be very specific on what we want you to do. But still, if you notice, there are a lot of things haven't been done by you guys when we talk about the assignment. Let me see if you look at in here. So the video presentation, citation is missing in some of the videos. So the title is important. The student particulars, which is your name and your matric number, school name, date, course code. When it comes to the content, some of you, I can see you don't follow what we ask you to do. I'm not sure with other lecturers, but if there is a guideline, please try to observe the guideline. But if you can add anything to it, just do it. But don't demote the guideline.
Hello everyone.
Okay, I want to start the next slide, which is for Aidil Azwadi. If you're ready, I will continue. Alright.
Today I want to share about chemical machining process. So let's start with the introduction. First of all, the definition of chemical machining. Basically, it is a material removal process in order to produce shape or pattern on the workpiece, but instead of using cutting tools, the material is removed through chemical etching by using etchant. Etchants are usually alkaline or acidic solutions and used for chemical dissolution to carry out this machining process. In today's practice, chemical machining is being used widely in the production of microcomponents. To our awareness, most technology are now getting smaller and smaller. Henceforth, the application of photochemical machining is very suitable for current technology demands. Photochemical machining is a type of chemical machining. It employs chemical etching through a photoresist stencil for the material removal process. And now we move on to the working mechanism for photochemical machining process. There are 5 steps. First, preparation of workpiece. It is very important to start with a clean workpiece to ensure the workpiece is ready for adhesion with the masking. Secondly, masking. A photoresist layer, which is a UV light sensitive material, is used as a masking to coat the workpiece. And third is scribing. Desired pattern is then printed onto the coated surface by scribing the masking, usually using laser. This will expose the areas for etching. And the fourth step is the most important one, etching. The material on the exposed area is then removed by spraying etchant to the workpiece. And lastly, demasking and inspection. The masking is then removed and the workpiece is inspected before approving. Now we go on to the advantages of photochemical machining. There are a few advantages of photochemical machining process. First, low tooling and capital costs, as you won't have toolware issues and so on. Secondly, it will produce a good surface finish. Thirdly, it can avoid stress on the workpiece as no force is used during the material removal process. The fourth, high machining accuracy, and that's the reason why it can machine complex patterns. And the last one, it is economical for medium to high production volume as it is able to machine many parts at a single time. Next is disadvantages of photochemical machine. Number one, it is only possible for metallic components. Second, scrap material is lost during the etching process. And third is, machining thickness is limited. And the fourth, the usage of chemicals may affect the health. And now we move on to the limitations. Basically, there are four parameters that could limit this machining process. They are the etchant concentration, etchant temperature, material properties of the workpiece, and the etching time. Generally, all these four parameters will affect the rate of material removal, hence making this machining process unfavorable. And a few efforts were done to overcome or at least minimize the limitations. For example, a research was done in 2018 to optimize photochemical machining process in manufacturing of microfluidic channels. The purpose of the study was to determine the optimum process parameters in manufacturing of microfluidic channels. From the study, it can be concluded that the optimum concentration of etchant, ferric chloride, is 750 grams per liter. The optimum temperature for the etchant is 60 degrees Celsius, and the optimum etching time is 50 minutes. This finding is crucial for the PCM industry, especially for the manufacturing of microfluidic channels, because the microfluidic channels are widely used as micromixtures for immiscible fluids, mixing of medicine, and many more. These are few examples of parts fabricated through PCM process. These are all micro components. First, the microfluidic chip, the one that we talked about just now. The second one is lead frame, which holds the integrated circuit or IC. Next is the fuel cell plate. And last but not least, surface mount shield for RFI or EMI. That's all for me. Stay safe and thank you everyone.
All right. Thank you, Idol. Uh, please give the marks. We want to proceed with the next presentation. we will proceed with the next one. Which is from Liu Jingfeng. Okay, Liu Jingfeng, you haven't submit the PowerPoint. Please submit the PowerPoint also, the slides to the assignment.
Hello everyone, my name is Liu Jingfeng and I am a student from School of Mechanical Engineering from University of Sains of Malaysia. And today I want to present my individual assignment of EPP212 Advanced Manufacturing Technology, which the title of my assignment is Electroplating. So let me introduce what is electroplating. Electroplating is a process that employs an electrical signal provided by an external power source to reduce cation of a desired metal in solution and produce a metallic coating, and it is also a type of electrochemical process. Electroplating can enhance in chemical, physical, and mechanical properties. Now I will show you a schematic diagram of an electroplating process. It contains four important components that are power supply, anode, cathode, and electrolyte. Cathode is the metal to be plated by another metal. Anode is the metal to be plated on cathode. Electrolyte acts as an conducting solution containing the ions in which anode and cathode are placed. Power supply is to supply a direct current to the anode and oxidize the metal atoms which dissolve in the solution. Now I will show you a simple animation of how an electroplating process undergoes. The electroplating process contains copper acts as anode and brass acts as cathode. And the electrolyte is copper sulfate. First, the cathode will undergo reduction to release electron, and the anode will undergo oxidation to produce copper ions, which will be plated on the cathodes. And the electrons will flow through the connecting wires to the brass cathode, and it will attract the copper ion to be attracted on the brass on the surface of brass cathode. Now we will discuss about the advantages and disadvantages of the electroplating process. The advantages are: make a product that has corrosion resistance, make the product that has mirror-like surface finish, reduce the cost, improve the mechanical characteristic. Workpiece is subjected to low thermal load and used as decorative purposes. While the disadvantages are: produce a non-uniform plating, the electrolyte might cause environment problems, hard to plate at holes and sharp angles, high manufacturing costs and long process time, and hard to control the uniformity of the plated surface. The current study to resolve the limitation of electroplating process, the additive often added to produce smoother surface. Increase of average current density to contribute a higher micro hardness and strength materials. Higher energy pulse enhance fiber texture of workpiece. Addition of mist suppressant above the plating rings to help in removal of toxic gases, exceptional cleanliness and dust filtering to minimize the effect of carcinogen to release to the environment. Next, we discuss about the example of part manufactured by electroplating process. First one is semiconductor. The example of semiconductor that produced by electroplating process are diodes, transistors, and integrated circuits. Electroplating process possesses the capabilities of producing a high quality of semiconductors. Then, the automobile. The parts that produce are power steering system, brake system, and chassis hardware. Through electroplating process, it will allows it produce a vehicle that has corrosion resistant, wear resistant, and tarnish resistant, which will prolong the lifetime of the vehicle produced. And the last one is food industry. The example of parts produced through electroplating are tin foods, tableware, and food container. Electroplating process produce tableware that plated with stainless steel can help in prolong the lifetime of food plating tools that can prevent rust. In conclusion, the potential of electroplating still not be decently exploited, but by the evolve of electrical processes, it will lead to a series of process innovation. So, electroplating will be deployed more advanced in the future. That's all for my presentation. Thank you.
Alright, we watched the video. I have to correct some of the mistakes in the video. First, it should be very clear what do you mean by electroplating is used in diodes or transistors. It's a very controversial statement. The next one is about he mentions about stainless steel electroplated for food industry. Stainless steel itself is a very good alloy. I'm not sure what does he mean, but what kind of coating or electroplating has been put on. So these are controversial. So when you are talking about, you need to give an example. These tins, the reason they call it tin is that because they are being electroplated by tin, or they have been deep coated, deep melted, coated by tin. So it means that the steel sheet has been going through a hot bath of tin, molten tin, and then it is being coated from both sides or from one side. It depends on the process, but that one is not electroplating. So we have to be careful when we are talking about a process. And here when you are
by the evolve of ocean from
writing
the
about
lifetime
conclusion,
of food practically exploited.
why don't you write a few text to show that the conclusion. So it is a communication way of presenting the work. The people, they can follow the text also. All right. I hope you get my points. By the way, thank you very much. All right. Do you guys have class after this or no? If you can hear me, can you please write me back? Okay. I I will disconnect from here. Please, those who haven't submit the assignment complete, please do the complete assignment submission, both video and presentation slides. And let's meet on Monday. Um, Either on Monday or the next Thursday, I will take a quiz, because when I go through your quizzes, the marks are not very good, honestly. I don't want you to lose the opportunity of a better output. So we will take another quiz that I can replace with your existing one. All right? Okay, have a good day. Stay safe. Hope we can meet each other soon. And then take care. Thank you.